In this question, we've been presented with a situation where a group of A-level chemists have determined the mass of a given amount of moles of sodium hydride. What we've been asked to do is calculate the value of the mass they determined, and we've been asked to give our answer to 2 decimal places. So how would we potentially approach this question? And beyond the issue of approaching it, would we need the periodic table, for example, to approach this question? Okay, so in this case, we've been presented with a given number of moles, and our target is to calculate the mass. Now, the formula that's relevant here, you can have a go at trying to come up with, okay, well, what's the relevant formula? I'm going to go ahead and go into that. The formula that's relevant here is the fact that mass, and this is all in grams, so mass in grams is equal to the moles multiplied by the molar mass, right? And that would be in grams per mole, right? So, and what we've been asked to figure out is the mass, right? Now, in this case, when we look at the actual question, what we have to ask ourselves is, well, what do we need? And what do we have already? What we have already, if you look here, we've got the number of moles already, right? So this, we have it. But what do we need? What we need is the moles, but we also need the molar mass, right? To be able to calculate the mass which you've been asked to calculate. So, as I asked, initially, do we need a periodic table? Well, we need the molar mass, and in the question, we've not actually been directly given the molar mass. However, what we have been given is the relevant compound involved in the question, and in this case it's sodium hydride, and we've even been given, in this case, the formula. So the answer would be yes, we do need the periodic table to work out what the mass would be, right? We need that because we need the periodic table to work out the molar mass of the sodium hydride sample. Now the formula, so if we just refer actually to a segment of the periodic table here, the formula which we're going to need to use is the fact that the molar mass is equal to the sum, so I'm just going to use the sum symbol here, is equal to the sum of the atoms of element, so that's like the number of atoms of the element, multiplied by the relative atomic mass of the element, right? So that would be how we calculate the molar mass, and this would be applied to all of the different elements present in the formula, or in the given compound or molecule, right? So in this case, if we're looking at what is the sum of the atoms of the element, well, for each of these we've got sodium first of all, so we've got 1x sodium, And for the hydrogen, we've got 1x hydrogen, right? So in each of these cases, we're going to need to multiply each of these by the relative atomic masses. So for sodium, if we refer to the periodic table, we can see that the relative atomic mass of sodium is 23, right? So therefore, what we're going to be dealing with is 23 multiplied by 1, right? And so as what we're building here is the sum function, right? So 23, and we need to add this to what the hydrogen component. So for hydrogen, if we look at the relative atomic mass, we can see it's 1, right? So 1 times 1, and this therefore fulfills our equation for the molar mass, what we actually need to work out the molar mass. So if we just work out what this is, now before I go on, I'm just going to clarify something. This is obviously quite a straightforward example. We've just literally got 23 times 1 plus 1 times 1. The reason I've gone into the formula for it in a formal way is so that you can basically take the principles, and even if you have a very complicated example, a formula with a bunch of different elements, a bunch of different numbers of those different elements, that if you have the formula, you're going to be able to work out the molar mass from it quite seamlessly. Okay, so this, in any case, this is 24, right? So, okay. Now, what do we need to do with that? So that's the molar mass, and 24, the units we're going to use here is grams per mole. So what do we do with this? Well, as we know from the question, what we're trying to work out is the mass, right, of the sodium hydride sample, the 0.95 moles sample of that. So we need to take the moles and multiply it by the molar mass. And we have this in the question. We've just worked this out. And so we need to do 0.95 and multiply that by 24, right? And I invite you to have a go, work out what that is on your calculator, right? So if you do work that out, what you should find is that is equal to 22.80, right? So in this case, cross-checking this with the question we've been asked, is this our answer, right? Well, if we look at it from a numerical perspective, we've been asked to give our answer to 2 decimal places, right? And we have managed to do that. So it's given to 2 decimal places. I've added the O just to make sure it kind of, But in any case, what we actually need to do is consider the units. So this is, I think can be commonly overlooked sometimes, but we are given a mass, right? We do need to clarify what this is. Is it 22.80 kilograms, micrograms? What is it, right? So in this case, it's 22.80 grams, right? So then we ask again, well, is this our answer? And now we can kind of be satisfied that, yeah, this is our answer, 22.80 grams. Okay. All right.